Looks like we have a good critical mass, so we'll go ahead and get started. First of all, I wanted to thank everybody for coming. I know this is Zoom. I know you could be doing a million other things, including sleeping, eating lunch, whatever else. Maybe you're eating lunch at the same time as this event, which would be cool too. But I just wanted to thank you for coming to our first MacArthur Fellows Digital Roundtable. My name is Kala Echo. People call me Cal for short, and I'm the social media manager at MacArthur and help get this going. And we're really thrilled that you're joining us virtually. The pandemic has kind of prevented us from hosting events in person. So if you're familiar with the MacArthur Foundation and our physical offices, we would generally be maybe in a room with 100 people. You know, there'd be a lot of like handshaking, getting to know people. We'd have it happy afterwards. Unfortunately, we're not able to do that. But the silver lining is that we're able to collect a lot of folks from all over the world, all over the United States, and fellows that are in 3 different time zones. We got somebody in California, we got somebody in Minnesota, we got somebody on the East Coast in Massachusetts. So it's kind of bringing us together in that way. So that's really great. And making it more open and accessible to an audience is what we're really excited about. So we'll talk about the 3 MacArthur Fellows that we're hosting in the sciences, where we'll talk to them about what inspires them, how the fellowship has changed their work, and I'm sure a whole host of other topics as you guys are kind of bantering beforehand and talking about your experience as fellows. So I got to talk about really quickly about one of the reasons that we decided to do this event. So this year, this is part of the 40th anniversary of the MacArthur Fellowship, a milestone year that we're celebrating. And one of the things that we're really doing is highlighting the program's commitment to recognizing exceptionally creative and inspiring individuals. So we're celebrating this milestone in a number of ways. So I wanted to highlight just one initiative that we're doing. It's called Toward Common Cause. It's in Chicago. It's a multi-venue exhibition, and it features MacArthur Fellow artists from all over that are all over the city of Chicago. The fellows are from all over the world, I think, but they're artists focused in Chicago. It's taking place in 24 venues across the city, and it uses the idea of the commons to explore questions of inclusion and exclusion, ownership in public space. And I encourage you to check it out if you get the chance. It's called Toward Common Cause. So that's enough from me. We'll get us started. I'd like to introduce my colleague, Jay Goodwin. He's our science guy. He's the senior program officer in the MacArthur Fellows program. And he will introduce our esteemed MacArthur Fellows that we got here today. That we're really happy we're really glad to have you guys hear from them. So Jay is our resident STEM expert, as I mentioned. So what he does is he reviews and develops fellows nominations in science, engineering, and math. He also leads the program's engagement with experts in the STEM disciplines. Prior to joining MacArthur, Jay worked in industrial and entrepreneurial drug discovery. So he knows a lot about vaccines and all those things. I'm sure we'll get into that conversation in Corona and stuff like that. He's conducted research at Emory University. He's also worked at the federal level on a variety of policy initiatives at the National Science Foundation. So without further ado, I'll kick it over to Jay.
All right, thanks, Cal. It's great to be here with everyone this afternoon. I'd like to maybe set the stage a little bit additionally for the panelists, a brief description of what the MacArthur Fellows program does. We work to identify and celebrate people of outstanding talent and creativity to encourage and enable the pursuit of their own creative, intellectual, and professional inclinations. And I can say without hesitation that it's been a real honor and quite the opportunity to be involved in identifying and celebrating such remarkable creative people. We're certainly all inspired by their work, your curiosity, and your generosity of spirit. And I'm very excited to see how their work will inspire others. And that's what's wonderful about having this opportunity to talk with them in a little more detail, to see how they will continue to positively impact the way we understand the world around us and how they can help us rise to meet the many challenges we face today. And so with that, I'd like to introduce our panelists. First, Damien Fair is a 2020 MacArthur Fellow and cognitive neuroscientist at the University of Minnesota, advancing our understanding of brain functioning with his work through how distinct regions communicate within the brain and develop in both typical and atypical contexts. Next, I'd like to introduce Jerry Mitrovica. He's a 2019 MacArthur Fellow and a theoretical geophysicist at Harvard University, helping us understand the dynamics and structure of the Earth's interior and developing models to better predict the magnitudes and sources of sea level change in the geological past, as well as in the modern world. And finally, Victoria Orphan, who is a 2016 MacArthur Fellow and a geobiologist at Caltech, who is shedding new light on the biogeochemical processes underlying the cycling of nutrients and energy that shape the Earth's climate through studies of microbial communities in extreme environments. And so with that, I'd like to start with a few questions, and we'll start with Damien. And the question is, if somebody isn't familiar with you or your work, what would you tell them about what you do and why you're passionate about it?
So thanks, Jay, and thanks for the introduction. So like you noted earlier, my work studies the developing brain. We use non-invasive techniques like MRI to understand and characterize the principles of brain organization, both in how it's structured and also how it's functioning. We study primarily, like I said, in development from infancy through adolescence, all the way through young adulthood. And we use these trajectories to try to understand developmental disorders like ADHD and autism and other types of mental health disorders. I'm also a co-director of the Masonic Institute of the Developing Brain, where we're trying to foster healthy brain function across the lifespan. The gist of that work is that we're trying to break down various types of silos of expertise, with the idea being that if we're going to make progress, we need to be able to kind of combine people who are good with development and neuroscience and imaging and engineering and community engagement and outreach and business leaders and policymakers. We need to start forming more information bridges so that the impact of our work can be larger than any individual part. My passion for what I do really revolves around just the idea of neuroscience itself. Understanding and characterizing the brain brings advances in healthcare, education, technologies, economics, the stuff that touches us every day. There are more direct, obvious things like diagnostics and therapeutics for things like disorders of aging, or Parkinson's disease, Alzheimer's disease, traumatic brain injuries, of course, mental health disorders. But there are other ways that our neuroscience really affects our society, and it's probably actually the bigger part. So our judicial system is now using neuroscience to understand, improve rulings related to eyewitness testimonies. Neuroscience in characterizing decision making has been used for centuries in finance and advertising. Deep learning, artificial intelligence, stuff that now resides in your phones, in your cars, in your kitchens, in your internet searches, everywhere, originated from theories and research related to how the brain develops. That's where these things came from. So there's simply no corner of our society that's not being touched by neuroscience, and it's really becoming more ingrained, and it's what really drives me to learn more.
That's wonderful, Damien. I really appreciate that. I will turn this over to Victoria for her thoughts.
Great. Well, thank you for having me. I'm Victoria Orphan. I'm a geobiologist and microbial ecologist at the California Institute of Technology, and I study microorganisms in ocean ecosystems and how they interact with each other and influence globally important cycling of elements like nitrogen, carbon, sulfur, and greenhouse gases like methane. And many of these processes in nature are carried out by interacting microorganisms, very diverse microorganisms in the environment. And the major challenge that faces us is that most of these microorganisms haven't been cultured. So we haven't isolated them to study in the laboratory. And this means that we basically have to go to the environment themselves to try to figure out how these processes are working. So it requires a bit of detective work. in trying to figure out which organisms are there, how they're interacting, and how they're influencing the transformation of chemical and physical matter in the environment. And so for me, in my research, detective work means bringing together a molecular and geochemical toolkit. So this could be genomic sequencing, use of fluorescent probes and microscopy to visualize the organisms in the environment, and then applying geochemical and isotopic tools to figure out how they're transforming different elements in situ. And because these processes are occurring on the scale of microns, really what we try to do is optimize techniques and miniaturize them so we can study these processes at the level of individual microorganisms to really get at the nuances of how these things are happening and how these organisms are interacting. So for me, my particular passion is in microbial symbiosis, so how organisms cooperate with one another to carry out feats of chemical transformations that neither organism could do on its own. And really a fascinating example of this is this process known as anaerobic oxidation of methane, which is a molecular symbiosis between a methane-consuming archaea and sulfate-reducing bacteria that are collectively responsible for consuming most of the methane in the deep ocean before it can have an impact on climate in the atmosphere. And these organisms haven't been cultured in isolation in the laboratory, but we can go using submersibles to the deep sea and find these natural laboratories, places where methane is venting at the seabed, and collect samples to try to understand how these organisms are conducting this globally important process and how they're influencing these really unique ecosystems in the deep ocean, these chemically fueled communities that have unique animal life. And it's really just a fascinating place to go. So the thing that really excites me is that I get to be part explorer in looking at these deep ocean ecosystems that haven't been looked at very much by scientists, and also to be able to put on my hat as scientist and try to understand how these organisms are shaping our climate. And the other growing value in the research is this idea that these ecosystems are potentially under threat of resource exploitation due to things like deep sea mining and oil and gas exploration. And we know so little about these deep ocean ecosystems that it feels a little bit like a race against time to try to better understand how these ecosystems function and how they're influencing the surface world that seems remote to most people. So I'll turn it over to Jerry.
Thanks, Victoria. Victoria and I actually have some overlap, not in the strict sense of science, but we look at climate change from a different angle than most, right? When you think of climate change, you think of extreme temperatures, droughts, floods, things of that nature, right? But climate change is manifest in all sorts of ways. And one way, and one of the papers I've read of Victoria's is sort of a consensus document her and colleagues wrote on how would climate change alter microorganisms in the ocean? How would that alteration then feed back into the climate system? As she's told you, methane is a strong greenhouse gas. The ability of these organisms to take in methane, to store them or to emit them, is really going to be an important question moving forward. I work on different kinds of problems. I'm a geophysicist. So I study, for example, if an ice sheet melts, how does sea level change? Half of my career is spent just saying, no, the bathtub doesn't work, right? Another thing I do is I look at the way the Earth's rotation is altered if an ice sheet melts. If the West Antarctic ice sheet collapses, which unfortunately it seems to be starting to do, the south pole of the Earth will move 0.5 kilometer towards the West Antarctic, and that in itself will feed back into all sorts of processes in your systems. So these are subtle effects that capture this sort of manifestation of climate change that perhaps have received less attention, I think, in the past. When a glacier melts in Patagonia, for example, the crust will deform because the glacier is losing mass, there's less weight on the Earth will rebound, and measuring that can be a very effective way of monitoring the mass of that glacier, right? So all of those things add up to the kinds of work I do as a solid Earth geophysicist who also studies the oceans in a different way than Victoria does. I visited Caltech several times, Victoria, but I've never come into your lab because, well, I'm a hypochondriac and I try to stay away from microorganisms. But other than that, why am I passionate about why the others have spoken about that? I just, science, the best science is sometimes counterintuitive. And a lot of what I do and a lot of what I explore is counterintuitive. I was really influenced as a young physicist by a Caltech famous physicist, Richard Feynman, who used to bring, he used to start his lectures by saying, how many piano tuners are there in Los Angeles? And everyone's thinking, well, I have no idea, but he showed that your intuition can get you pretty close, right? Just ask a few questions and eventually you'll come up, and I used to do that. I stole Feynman's idea with my physics classes and we'd come up with a reasonable estimate. But then he used to say, and I'm paraphrasing the great Richard Feynman, but he'd say, we need physics when our intuition fails us. And in many ways, the things that I study are examples where intuition really fails us, right? The most prominent example of that is if an ice sheet melts, if the Greenland ice sheet melts, it will be surprising to those listening to this, but sea level will actually fall, not rise close to Greenland because of gravitational effects that I may or may not get into here. But that's very counterintuitive. It's so counterintuitive that sea level scientists sometimes have to be convinced of the fact, right? And it falls within 2,000 kilometers, 1,200 miles of the ice sheet. So if the Greenland ice sheet collapses, sea level is going to fall in Scotland. It's going to fall in Iceland. It's going to fall in Newfoundland, Canada, where I'm from originally. And so those sort of counterintuitive aspects of the field really attract me because I think you have to step back and think, how does this work exactly? You have to look into it. And that isn't quantum chromodynamics, which Feynman was famous for. That's just Newton sitting under the apple tree. And so using physics to explore counterintuitive observations and results is sort of my bailiwick. It's the area that gives me, I think, the most excitement, right? The other area, and this is where I'm really impressed by Damien and Victoria, the other area that I'm sort of getting into is how do you somehow find the, I hesitate to say truth, but find the kind of element, the fundamental aspect of such complex systems. I mean, Victoria just talked about the ocean. The thing that I was surprised at once when I heard a talk by one of Victoria's colleagues is we don't know most of these species in the ocean, right? We have no idea. And the brain has to be the most complex organism of all. How do you pull out? I'm really interested in this idea of, where do you start when you're faced with such complexity? Where do you start, Damien? What's your starting point when the brain is such a complex organism?
Well, it's fascinating. I mean, the reality is that it really does kind of start with a bit of your intuition. It does. So, like, for example, I mean, I love patterns, right? And I think we all do, Victoria. That I made a career at several levels by simply trying to piece together the meaning of a given pattern. So patterns and personalities, navigating education systems, raising children, every aspect of our lives, and one way or other seems to be this pattern recognition problem. Understanding the brain so far has been one of the most challenging with this regard, just like you're describing, Jerry, right? But it's also why I love it. And you start by making some types of intuition based on some pattern you see, and then being rigorous about testing that idea. Richard Feynman, by the way, is like, he's one of the guys that inspired me very early on with the book, What Do You Care What Other People Think? Is this time when he was talking about the book on his experiences with kind of investigate the Challenger explosion, if you remember. And I remember several anecdotes in that book that kind of pushed me towards doing a lot of the science that I do today, even though I didn't go into physics or anything of that nature. But it's another aspect of the connection here, Jerry. But I'd say in general, that's it. You recognize some pattern in the system, the way that you're measuring it, and then you try to test to see if your intuition is actually correct.
I'm going to step in for just a moment to let the audience know that we are collating the questions that they're providing, and we'll get to those after this part of the panel discussion. So I wanted to move to Victoria, this sort of question of, and it's nested into this idea of what you're passionate about, but how have you been inspired to move into this you're pursuing?
Yeah, I think it's going to sound a little nerdy, but I am truly inspired by the microorganisms on this planet, and I could not have picked a better career. It was a course that I had in college in environmental microbial ecosystems that just totally blew my mind. Not only the existence of microorganisms in the environment, but their tremendous impact that they have on making for us. It just has never stopped being a topic that I've been excited about. And with technology coming deeper, can you hear me? I feel
Sorry,
like
Victoria,
can you guys hear me?
Yes.
Yeah.
Yes.
Can you hear me now?
Yes.
Yeah.
Okay. Yeah. So I don't know at what point, but microbes excite me. The thing that's been really tremendous lately is the ability to sequence deeply in the environment, and this has uncovered new phyla of microorganisms, and it's like for the very first time realizing there were insects on the planet, right? I mean, and so most of these organisms are uncultured. We don't know how they fit into the cycling of elements on the planet, and it's this really profound field that we really need to dig into, and the technologies are coming together. Damien in the beginning mentioned the importance of having this sort of umbrella to bring in people from different disciplines to be able to really crack this nut. And geobiology is kind of a hotbed for multidisciplinary science. And it's one of the things that I really love. And I'm inspired every day by my colleagues in what they can teach me, coming from the geochemistry field, from physics. And it's really a wonderful opportunity to be able to understand these Earth systems through the lens of this multidisciplinary science.
How do you know, Victoria? You sample things, you go down in that submersible, which sounds incredible, and you sample. How do you know you can reproduce that complexity in the lab? Because you might have you talked about symbiosis, you might have 4 or 5 of these things all playing off each other in the ways biologically they do. It always made me amazed at your work and your ability to bring that complexity to the lab.
Yeah, it's one of the advantages and challenges of working on this process of methane oxidation is that the microorganisms get very little energy out of this coupling of methane and sulfate. And so this translates to very slow growth rates. So every 3 months, they'll make a copy of themselves. And the benefit there is that we can keep these things going for long periods of time in the laboratory, and we just monitor how they might be changing over time. And we have to even do experiments on the seafloor, opportunities where we have oceanographic cruises. We can do sets of experiments that allow us to get the sea and come back and see how the community has responded, have grown in the presence of their sort of in situ habitat.
Sorry, Victoria, I think we lost you, lost your signal there a little bit, so caught some of it.
Okay. What part did you miss? I don't know what's going on.
That's an impossible question to answer. What parts did we miss?
So they grow slowly in the lab. We can do those experiments, but we also now have the ability to do experiments directly on the seafloor. And so having opportunities to go back to the same place and do manipulations has allowed us to start to understand natural, which is quite a feat when you're, up the seafloor.
I'm curious, so Victoria, Damon, were you inspired? We're sort of all inspired by people within our field. We have sort of touchstone people that you should never underestimate the importance of role models, I think. It's one of these issues that comes up, and one of Victoria's colleagues at Caltech, Dave Stevenson, is one of those role models for me. When I do something, I often wonder, would this pass the Stevenson test? Would he look at this and say, nah? So we all have those people, but what about people outside of our fields that have inspired us? I came from a family that, with the exception of an older brother, had no science background whatsoever. And so our discussions centered on art, music, politics, Renaissance history. One of my sisters was a concentrator in that. And so I think it's meant that I've sort of been inspired by a lot of people outside of science, creative people inside scientists, like the fellow I just mentioned, Dave Stevenson, where you wonder, how did he think of that? What was it that tweaked him to that incredible idea? But also creativity outside science. I'm a rock fanatic, and Charlie Watts died yesterday, the Rolling Stone drummer. And when I listen to the Rolling Stones records, I wonder, why is it that they're so hard to copy? And it was because of Charlie Watts, right? He was a jazz drummer, and he did things a little bit differently. And I'm fascinated with this creativity, whether it's in science or out of science. One of my favorite artists is Rothko, and I wonder, did he consciously know that bringing these colors, these shadowy images together would somehow resonate in a way Damien might understand in a very detailed way in our brain, to say, yeah, that's why I'm crying looking at this painting, or that's why this painting makes me look energetic. And so creativity means doing things that people haven't done. And the process and admiring people who have shown that creativity in a lot of disciplines has really inspired me, particularly in those sorts of areas of art and music that I'm particularly interested in. Damien, what about you?
Yeah, I mean, I'm it's funny because for me it's actually very difficult sometimes to pinpoint down someone specifically that inspires me per se. or rather I probably could, but my ego wouldn't necessarily allow me to let them know. The reality is, over my lifetime, I've had, in a very similar way, Jerry, that I've surrounded myself, or maybe I've gotten lucky to have surrounded myself with some fairly incredible people, just amazing personalities, drive, vision, just simply some qualities and characteristics that have always pushed me to do better, right? So in many respects, because of my position and the various accomplishments I've had over my career, some think of me as a leader, but really the characteristics that make me me are really just an accumulation and a combination of the talents and makeup of these folks around me. And almost anybody close to me, I can see and visualize qualities in them that I wish I could emulate, and so I'm often inspired to try, and really see if I can do that, And I can't remember really a time in my life where this hasn't been true. In high school, I had some amazing, just overachievers that I'm still close with today. That, while I was primarily a basketball player with regard to extracurriculars, I began to compete in all sorts of types of activities that I would never have done on my own. Debates and plays and math team and music. I mean, it was, it would drive my coaches crazy. When I was in graduate school, I met my wife, who was annoyingly accomplished, right? She had written a book, in college that's still selling. She had come from Ethiopia for college and only been in the country for 5 to 6 years, and was just running laps around me academically. There's no question that she inspired me to pursue kind of a certain level of excellence and professionalism in my work. And having exposure to someone like that really takes you out of your comfort zone and inspires you to do new things and try to pursue this knowledge from different perspective. And I get to chomp on that every day. And there are just so many examples, so there are people in my lab, trainees, that inspire me. These guys are simply smarter than me in most of the topics we're studying. It makes me want to learn more, to get to their level. I have a couple of folks now managing my lab who are just simply, they're simply phenomenal. They do it so much better than I can. The other day I was, scouring the internet, trying to look at articles about how to be a better, manager. That inspires me. I actually just had a conversation with another MacArthur Fellow, Steve Coleman, yesterday, who has all these interesting sax player, who has all these interesting ideas about patterns and learning regarding related to rhythms in music, which I thought was, was fascinating as far as thinking about like, oh, how could we test that and explore some of these things, my son is now a teenager and he's runs faster than me. So I'm like, I gotta catch up. So now I'm running more, so I'll end, but I just want to emphasize that for me, often my inspiration comes from the folks that I touch, on the daily. I just try to get to their level in something, and that's kind of how my brain works.
What are your thoughts on that, Victoria?
Yeah, I
Sorry, go ahead.
fully,
I'm sorry,
I
Jerry.
fully, yeah, I agree that there's a lot of inspiration to be gained from the people that you're interacting with on a daily level, and I love the intimate connections there are between the sciences and art and music, and I always gain inspiration from talking to my colleagues who are musicians and artists, and I'm always in awe of their creative spirit and how they can convey these messages to a broader audience. And I think trying to capture a little bit of that as a scientist, to be able to impassion others to be as excited about science as we are, I think is a gift. And so I try to take inspiration from my creative colleagues and make sure that I keep a diverse friend base that isn't all just like-minded scientists. And so I love hanging out with my musician buddies as well. So yeah, MacArthur Foundation sort of is a perfect example of bringing together and providing these opportunities, I think, for scientists and other creative types to merge together.
Damien and Victoria both mentioned community in one way or the other, and community is very important. With outside of science, certainly some of my friends are scientists, some are not, but also community within science. You know, we have to be honest, there are some fields of science, I'm sure, that are sort of cutthroat and extremely competitive, but I've been lucky that I've worked in fields that have been very supportive of young people, that have kind of fostered a community. Graduate students are supported, you know, they are my community as well. I've been really lucky to have had some really astounding graduate students, most. And so community is important, you know, and meeting these people that are, you know, I remember being at a conference once, and there was a very famous scientist, Nick Shackleton, nephew of Ernest Shackleton. Victoria, I don't know if you ever crossed paths with Nick Shackleton, but very famous person in studying ancient climate by looking at ocean sedimentary cores. And I'm at a conference, and you're put up, all housed in some hotel, in this case, a former convent that had been, and he was, lucky for me, in the next door to me. And Nick played the clarinet, and he collected clarinets. I think it was a clarinet. It was some wind instrument. I'm not very knowledgeable of wind instruments, but I think it was a clarinet. And I heard him playing, and I was on my patio, and he was over, and then he looked over and saw me, and we started a discussion, completely accidental. And it sort of touches on one of the themes, Jay, that we've talked about. But he gave me advice. So he was my community for a while. He gave me advice that I've always, you know, Damien talked about reading Feynman's book, What Do You Care? Shackleton said to me, you seem busy. And I said, yeah, I'm doing this, I'm doing that, I'm doing this. And he said, yeah, you gotta give yourself time to think, right? Got to take a few hours every day to give yourself time to think. It was the best advice I'd ever been given by a senior scientist. I go for long walks where I think. Sometimes it's about Charlie Watts, the Rolling Stone drummer, but sometimes things come to you in this. And it was great advice from somebody who was really very supportive of young people. It taught me that I have to pull them aside too on occasion, and say, hey, give yourself time to think. Why are you on 52 committees? Why are you accepting everything? And to be honest, this is a particular problem for females in STEM, right? They're placed on too many committees because we obviously want a gender representation. And you know, most of my recent graduate students have been women, and I tell them, say no, give yourself time to think. Take a walk through the park if you start getting anxious about getting something in. Best advice I've ever given. And the other great advice, Damien, comes from that cover. You know, Shackleton also said to me, you know, what do you got to lose? Take a risk, give yourself time. That was his attitude, right? If the idea doesn't work out, or the paper doesn't work out, doesn't matter. And I've really taken that to heart. And I guess that's the same thing that Feynman was saying, Damien.
Yeah.
That raises an interesting question that, and you touched on this a little bit, Jerry, which is one of the challenges in STEM, of course, is this issue of representation and diversity and nurturing and supporting creativity. And I certainly welcome any thoughts that you all have on that. And Jerry, you sort of voiced your thoughts on that. Maybe Damien, you have something that comes to mind.
Yeah, I'm the diversity question. From my perspective, this is one of the most pressing problems that science is facing right now. Is a lack of diversity in our laboratories and institutions, and just the STEM workforce, in general. So the impact of discrimination and structural racism in our society on individuals is extremely large, particularly in communities in places like where I live in Minnesota. And from my personal view, of course, this is a matter of fairness, which drives, the importance of reducing inequities in our society, in education, healthcare, economics, etc. But as a neuroscientist, right, these issues are lessening our chances of discovery and prosperity in our communities. As we become more diverse in growth, the growth is we grow and the society grows and we become more. The growth is being driven by underrepresented populations, and so maximizing the opportunities for everybody is really critical. I actually, when I won the, after I got the MacArthur Award last year, they give us an opportunity to write a quote, right? And you get one quote and you can say, and I actually wrote my quote on this topic because I do think it's so important. So maybe I'll just read that. You can kind of understand where I'm at. So every step towards a deeper characterization of brain function brings these advances in healthcare, education, technologies, economics, and other enhancements in our society that deeply touch our everyday lives. And however, continued progress will not come with a homogeneity of ideas, thoughts, education, experience, and culture. We need to embrace our variability, our diversity, and provide access to this pursuit to all the talents that exist in our society. It could be argued that the driving factor of discovery and advancement of nearly every civilization has been the result of human variability, where some outlier, oftentimes of being minority status, pushed the society in a way that no one could have ever imagined. Ironically, in the sciences, our ability to proportionally value the importance of this principle has been limited. And so I'm hopeful at this junction in our history that we can harness our privilege and awareness to embrace a change of course. So, I think you can kind of get a sense of why I think it's important. It's not just about fairness, but actually the science is being slowed by not embracing all of our talents.
Yeah, I very much agree with what you're saying, Damien. And as somebody who is working on climate systems and thinking about the environment, you cannot decouple racism and social injustice from the problems that we're facing in terms of making changes to the environment. And I think we need to be training our students not to be thinking about research in these silos, but really getting a much more holistic perspective on that. And I'm starting to see that a little bit more embraced in college curricula, but we need to do a lot more of that. And certainly my research would not be as successful as it has been without having diverse perspectives and experiences of all of the students and postdocs that have been in my groups over the years. And so it is the best way to advance our knowledge and science is by trying to maximize as many voices as possible in the sciences.
We have this view or people have this view outside science, very incorrect, that STEM research is not a creative enterprise. It's a kind of, you just set your 5 tasks, you do those 5 tasks, you come to the answer. And that's simply not true. Creativity is as important in STEM as in any other field. And diversity is the stuff that creativity is made of, right? I mean, when I have when I meet people who don't really fully understand why diversity is so important, I give them very simple examples. I tell them about my own neck of the woods and what I've seen. And I think I shared this story with you before, but I look at a very diverse group of people that have worked in my group. I had, for example, one student who had no background whatsoever in earth science, took an earth science course with me, wrote his problem sets. Every single answer in these problem sets was wrong, but he tried something so unique that an earth scientist would not have tried. They just wouldn't have. They'd never heard of it, right? And I read these things and I said, you know, you're wrong, but this is really good, right? This is a really nice try. And he became a very successful graduate student and is now working as a scientist in Germany. And a second graduate student who I know I've talked to you about, Natalia Gomez, is now a professor at McGill. Natalia came to, well, she was a physics undergraduate, of course, but she came to the group after several years working as a prominent ballerina in Canada. And she's wildly successful. She's now considered the most important person studying ice sheet sea level interactions. And how did she get there? Well, with the discipline of a ballerina. She's the only person I know who could sit down at a desk for 10 hours. I get up every 15 minutes and just walk around. But second, just from her background, had a really, just a different way of thinking and a different way of understanding the sort of heart of the matter in a problem. And so I know those are specific examples and might not resonate with people, but for me, they do, because they showed me this is, if I face a person who says, well, diversity, yeah, everyone wants diversity. Those are the examples where I say, my group has been immeasurably contributed to by people that come into it without the typical background that of an earth scientist. And it's just proof. It's not just a slogan, right, that we want to now hold tight and protect ourselves with. It's the reality of STEM research, that if you come to it with a slightly skeptical attitude of textbooks and articles, respectful but skeptical view, with a different set of talents, you can really make incredible progress, as those two students and many of my other students have done.
That's a great story, a great narrative, Jerry, and it raises a thought that I think is that it's a thread that runs through all of the fellows over the 40 years that we've been identifying and celebrating fellows. Is this creativity sort of goes hand in hand with this remarkable level of curiosity and curiosity of spirit, and a willingness to engage and take risks in ways that are enveloping and holistic, as opposed to sort of exclusive. It's more of a statement than a question, but if it prompts any thoughts that you would all like to share, we'd certainly welcome that. I'm going to go to Victoria and pick on her.
Well, I agree that creativity is sort of the secret sauce for, I think, success in the field. And what Jerry was saying really resonates with me, that you don't want to be too constrained by the research that has been done for you and locked into certain idea states. And so really allowing people to have sort of freedom to explore out of the box thinking is really valuable. I have a colleague at Caltech who has all of the undergrads write what they call a nut paper, which is, come up with the craziest idea and try to justify it. And some small fraction of those actually have a kernel of something that really goes on to doing something amazing. And so it's really, again, the spirit tech writ large to embrace creativity and to do things off the beaten path. So
how do we reinforce that view? The reality is young faculty, STEM faculty, went to universities, have a tenure obstacle they see there, and tenure, and I understand, and I'm an advocate for tenure, I would never argue against it, but tenure can also have the negative results of keeping people in the straight and narrow, right? And I'm just going to keep doing what I do, I'm going to publish these papers, I'm going to get tenure, and then it's all going to change. Except by the time you get tenure, you've developed a pattern of doing research that is hard to break. And I wonder, how do we reinforce what Damien says? How do we reinforce, doesn't matter what other people think, what do you care? Just do what you love to do. It is important, but it's just really hard. Young faculty are under so much stress that it is really hard to say, forget it, just do what you want to do, go where you want to go. It's a problem. Right?
Yeah, it is. I mean, I've been thinking about this, a little bit recently about what can you do. I mean, the reality is that we have very structured and ingrained systems that are really the only way to kind of change some of these patterns is by changing what you value, changing what you're incentivizing, and it does start with some structures like these tenure structures. I mean, actually, there's I don't know if we'll call it a movement, but I've seen a few universities start to incorporate like directly DEI into as an actual category in promotion, right? So instead of simply doing service and teaching and in your science, right, which is the traditional kind of categories of tenure, that you actually start putting inside that structure other types of incentives that can help you with promotion, and those kind of structural changes may help kind of change some of that dynamic, but it's much beyond that, right? Because if you think about, how do we get our funding? What do you need to prove to be able to get your funding, and maintain your career, when you go and try to publish a paper to give it to an editor, how is it going to get published? This, in fact, we're seeing this crisis in our field quite a bit now, because, and it's really no different than any other field where nobody publishes, or people do, but it's more rare, right? Nobody publishes their negative findings, right? But they're so important, to put the context around what we're seeing to make sure that the answers are right? But there's almost no incentive to do that, anywhere, even though it's like for the science, it's super important. And if you're going to if you want to just kind of open your mind and ask a question and take a risk, and you need to be able to get rewarded for that as real science, because even if it's a negative result, it's just as important as the positive one, and so I think that there needs to be it's the same thing with getting funding. I call it the currency with my students. There's a specific currency. There's papers and grants. You start building up that tool, then you start, other things become easier, like getting more funding, right? And shouldn't necessarily have to be that way. So I do think that there's because that prevents, just like what you're saying, Jerry, prevents more thoughtful ways about doing the work, and so I do think that there's some, at multiple different styles of institutions, there needs to be some multiple structural changes with regard to what we incentivize if we're going to really change that dynamic.
Yeah, I agree with that. I think especially what I've seen with the students that are coming up, they really are very passionate about integrating not only the science, but also the outreach component. How can they have an outsized impact beyond just their publication record, and creating a new way of evaluating the effectiveness of scientists in academia, I think is really the only way forward. We should be embracing all of the extra work that people do beyond just the science itself. We need to have new types of infrastructure that doesn't overemphasize certain types of journals, for instance, and make that the only sort of evaluation criteria in some ways. I mean, there's a lot of work that needs to be done. Problem is, it's easy for us as tenured faculty to be able to shed these things, but it's very hard to tell a student who is really trying to launch their career and sees this as the roadmap on how to buck the trend. And so I don't have a good answer for it, but I fully agree we need to be making these very influential structural changes to how we think about academia and success.
Yeah, I tell my students, this is where I hit a brick wall, because I don't know the answer either. But I've just had this series of incredible graduate students in the last 8 or 9 years, all in faculty positions now. And my mantra to them is, academics is ripe for disruption. We hear about disruption in a lot of fields, but academia holds on to this model, right? We could talk about this for another 3 hours, right? It holds on to the model of the pyramid, right? It's supervisor, postdocs, grad students. They publish papers to the greater glory of the person at the top of this pyramid. You get tenure. They then go and get their faculty position and they establish a pyramid. And my students will ask me, and they'll say, well, how do I do that? I don't know. I just don't know, because of these pressures, right? But, if there was a way to shake up academia, to get rid of that pyramid structure, to make people understand, it's what Damien said, it's cultural. We have to change the culture, right? And I don't know how we do this. That's my limitation, but I hope in 20 years, my students aren't in the same model that I am today. I mean, I've enjoyed this model. I've loved it. I've helped young people progress, but we need to change it a little bit. Some of my former students are scared to do outreach work, right? Because it takes so much time away, but they love it, right? They go to, they have these science in pubs sort of thing. They love that stuff, right? I don't think I'd be great in such an environment, right? But they love getting out there, and I wish they felt less constrained so that they would do more of that stuff, because they just love it.
There was a question from the audience that sort of dovetails into this. The question is essentially, what do you think are the limits of science in addressing social and ethical problems? And I think that's sort of a corollary to this question of how is academic science thinking of growing beyond its limitations. So I don't know if that's something you'd like to touch on. It's a big question, right? And of course, we're dealing with major challenges that all seem to be coming together at this very moment. But any thoughts you would like to share on that would be welcome. And I'll start with Jerry, because I think you sort of were leading into that.
Well, I have an anecdote about that, and that is that every year when we have incoming graduate students in my department, we have this really nice thing, meet the faculty. And one year, many years ago now, actually, I invited an ethicist to come in, right? Because if you want people to make the correct ethical decisions, and you want them to understand the broader ethical context of their work, and I think I can imagine Damien, Victoria, and I all have these issues. I mean, studying the brain must raise ethical issues. Studying climate change, some of my colleagues are climate engineers, right? That opens up all sorts of ethical issues. How do you tamper with climate, right? is that a good idea? And having been born in Australia, where people tried to tamper with the environment by introducing all sorts of animals, you understand what the limitations are of that. I think it's possible. I think in climate and these IPCC reports that are published, there's a real effort to try to understand how we manage our science in an ethical way, how we understand, for example, as I understand, because we do some work with indigenous communities, that climate change inordinately affects those that are least capable of dealing with it, right? And indigenous communities at the top. How do we make that a central part of our research? We have to make students aware of ethics. I know it sounds silly, but get them to ask a question. I ask my students a question sometimes. I say, you're writing a paper and you're asked to review a paper, and it turns out that that paper has exactly the same idea that you're writing up. What do? We don't have to answer that question here, but it's important that they think about those things. You come up with a solution that you think has a 5% chance of instead of helping climate, hurting it. At what percentage level are you willing to accept that, right? Getting our students to think about those ethical dilemmas is the start of that. And I do think the climate scientists think a lot about those issues. You're always confronted with them. And it's a central part of climate change research to understand what the ethical implications of your work are. I don't know if you agree with me, Victoria.
Yeah, I do. I also think as scientists, oftentimes we have the opportunity to travel the world and visit exotic sites for sampling. Rarely, at least people of my generation and earlier, I think, were we well trained in how to engage the communities and be respectful of the places that we're visiting. And I'm starting to see that change as well. And again, this ties back to enriching your science by including diverse perspectives. And so I do feel like it's our responsibility beyond just planning these field expeditions, but to really reach out and try to engage and educate and involve as many of the local communities as possible, not only because it's the right thing to do, but also because it can ultimately help enrich your science in ways that are hard to predict. And so I'm seeing these changes starting to happen, greater recognition of this, but we need to be doing this much more on a grander scale, I think, and creating opportunities, having the opportunity to work across international borders, I think, is really important too. I think our funding structures within the US, at least most of the federal, it makes it really difficult to do that. So I would hope to see that kind of change happen.
Damien, you led off in the description of your work indicating sort of this multidimensionality or the sort of tendrils of the work that reaches out into other domains. Maybe you could address that a little bit more in this context of the impacts of your science.
Right. Yeah. So I mean, you know, as far as like the ethics question, I think that they're just like Victoria and Jerry is saying, is you know, it's having the discussions. They have to continue the discussions, and it has to be a part of the focus, because it is, many times it's very much about the perspectives of where you're coming from. And when you're doing cross-disciplinary work, oftentimes, you know, work, you know, from across different domains and cultures and different pieces of the world, making sure that those discussions are and the perspectives are up and center are really important, because a lot of times, you know, there's a lot of assumptions you make based on your own experiences, but really people can be coming at various questions in very unique ways, and having that front and center is definitely very important.
Yeah, what Victoria made a comment that really resonated with me. You know, I have an older brother who wrote a thesis on foreign aid and the importance that when we aid these communities, we understand them first. We don't just say, here you go, right? And I'll give you an anecdote. I wrote a proposal to help Inuits in northern Canada deal with changing sea ice conditions, right? Which have altered the way that they can move around and hunt in their areas and sustain themselves, right? And one of the reviewers wrote back, and the people involved in that proposal had very long-standing, decade-long connections to these communities. And in the first time that proposal was rejected, it was rejected because one of the reviewers said, you need an anthropologist. Now, I'm not suggesting that anthropologists don't have a role, because the idea was to study the Inuit. And I responded by saying, we're not studying them, right? We're providing them with the tool that will help them, right? They don't want to be studied in this context. They may other contexts where they do, but it was insensitive, right? It was treating them as a community that should be studied. We're responsible for sea ice conditions changing. They're not, right? It's our responsibility to find solutions or to give them tools to navigate that. And this whole idea of studying them just really turned me off. It was just the wrong thing to say, and they would never allow it. It's patronizing. We don't need to be studied. And the proposal got funded eventually when I had a letter from one of the elders saying, we don't want you to study us. You know, if that's what you're interested in doing, don't come. And that was a blunt enough letter, but it shows a kind of insensitivity that sometimes creeps up in academics. And you have to sort of face it full on. And so, you know, what Victoria said about understanding the communities that you work with, understanding what the implications are. We do this climate engineering, but how is this going to affect people in Bangladesh? How, you know, and the flooding that goes on there, how is it going to affect island nations, right? That's an important question to ask before you do any of this stuff, right? I'm getting a little bit.
We do have one question from the audience. This is a very specific question for Victoria that I will share. I want to make sure that we got this in. I have a few additional questions, one of which kind of follows on from Jerry's comments, but just to get this one in, the question is, are the methane processing microbes found near hydrothermal vents or also near polymetallic nodules? Now, that's very specific. Deep sea mining is largely proposed only near these nodules where this person is told there's not much methane leakage. Your thoughts on that, Victoria?
Yeah. There are two areas that are of concern for deep sea research and exploitation. One is this deep sea mining of precious metals, whether they're polymetallic nodules or mining actual hydrothermal chimneys that are rich in many of these metals. And there's also oil and gas exploration that has become much more economically feasible in deep water ecosystems. And so for the systems where we have methane hydrates, so like methane trapped as in ice form, in places where we see these methane seeps, those are areas that are potentially in danger of being disrupted through the oil and gas play. But the audience member is right that in places where we see these polymetallic nodules, that's not necessarily where we see methane seeping on the seafloor, but those are also very fragile ecosystems. They host unique animals and organisms. And again, you know, we've only begun to scratch the surface of understanding our own planet. Like 5% or less has been studied by scientists. And so we really need to get a baseline understanding before we start just blindly going in and destroying and reaping the deep sea.
Thanks, Victoria. I think this leads sort of subtextually to what Jerry was getting at, which is how we engage with the broader world outside our labs, outside our classrooms, and how we communicate, both in terms of putting context to work, but also establishing context for the work from the people we're working with. And you were walking down that pathway, Jay. I don't know if Damien, you arched your eyebrows if you wanted to jump into this one specifically.
Well, it's actually, again, like these are, you're hitting on topics that I've been thinking about deeply, in part because of this new institute that we're trying to kick off. Because there's two things that we've been thinking about in this front. One is that as scientists, of course, Jerry and Victoria are the exceptions. We're generally not that great of communicators. We have difficulty explaining and describing what we do and why it's important and all of this, you know. And part of that, I think, it's not all our fault. You know, we're not trained often to be good communicators. They don't teach us that in graduate school or anything. We just gotta pick it up. Or you have a really good mentor who kind of emphasizes it, you know. And so getting that information out to the communities and you know, policymakers, educators, things, you know, it becomes very difficult. So we've been doing a lot of work of trying to pair, you know, good communicators and communications folks with our scientists, so that they can learn, but B, the information can be more digestible out in the world. The other issue on this front, that's related, is that particularly when we're at universities, is we often find ourselves what I call like the university island. It's like these bubbles of, you know, people who generally think they're very smart, you know, and they have amazing million ideas. But as soon as you, oftentimes that idea may seep out into to a community member, they'll look at it like, why would you do that? Because that's not the problem, you know, and you'll see that some of the great ideas that we have are oftentimes not so great, particularly if what you're trying to do is eventually trying to touch somebody in the community. So we've been trying to think through ways to kind of break down make some bridges or break down the barriers and actually get, you know, what we're calling community scientists to be part of the entire process, from taking an idea, making a proposal, presenting data at meetings, so that there's more of a loop of communication where that could help essentially the scientists know and understand the meaning of what we're doing out in the world, but also that the folks out in the community or in the world feel like it's their own too, you know. And it's a hard process, but it's one of the, I don't know, it's one of the things that we've been testing or trying to test to see if it's a better way to do even some of the very basic science that we do. It's tough nut to crack, because again, it's changing a lot of culture, but you can see that there's kind of these barriers that we have to figure out a way to better break them down. I mean, you can see it already in our politics and all types of places where you're like, why are we not communicating this, you know, and you can just feel it. You can see it in our everyday lives. So thinking about creative ways to kind of break that down, I think is very important for our future.
Yeah, and it also adds, I mean, the thing about when I looked into Damien's work prior to this, and I already knew a bit about Victoria's work as a neuroscientist, but that sort of communication adds something else, because it adds an excitement for the field. Like, who is going to doubt that in the next 20 years, we're going to learn a lot about the brain, right? It's just this exploding field. Even a person who's not in the field realizes there is going to be a renaissance of sort of stuff. And for young to communicate, or as Victoria said, where we haven't even discovered most of these microorganisms. We're going to know so much more in 20 years. And communicating is important, because it sort of motivates people to think, wow, when students ask me what they should study, I think, well, what you love. But also look at fields that you think are they're just at the kind of stepping off point to an explosion of ideas. And as I say, you don't have to be a neuroscientist to realize that brain research is one of those, nor do you have to be Victoria to realize that understanding the world's oceans is going to be something that's going to experience an absolute renaissance and get people excited through that communication.
Yes, and you can even have both. You know, there are microorganisms we know now that are associated with the human body that impact the neurological systems. And so, so you could be looking at the interface even, yeah.
I want to be respectful of your time, and obviously we value everything you've brought to this conversation. It's been very rich and very informative and very inspiring. I thought maybe what I would do is end with one final question. Again, sort of in the context of inspiration, what makes you hopeful, particularly in these challenging times? So you can paint with broad brushstrokes.
Well,
Damien?
I'll just say why. I mean, I'm looking back at some of these junior people and kind of the energy and kind of motivation, and kind of their push for change is really, I mean, that is one of the things that's inspiring to me. And you can see that there's kind of new tools and capabilities to kind of overcome a lot of the naysayers who tend to be long in the tooth, so to speak, you know. And I feel like the younger generation has a real opportunity here to you know, bend the curve a little bit on some of the topics we've been talking about today, and that absolutely makes me quite hopeful.
Victoria?
Yeah, I think the technological development and how rapid things are increasing to provide scientists with tools to address some of the real world problems is very inspiring. I feel like, of course, the next generation of scientists are much more well-rounded and much more in tune with the world around us, besides just the specific science that they're working on. And that, of course, is, I think, a move in a positive direction. You know, in the pandemic, everybody felt, I think, a little bit isolated, but on the other hand, there was these creative ways of connecting more broadly with the community in new ways. And to me, that was also hopeful in terms of hopefully breaking down some barriers and thinking a little bit more about how to communicate with a broader audience and reach people, as this event is doing for us here, rather than just being the fellows talking amongst themselves. Being able to open that up more broadly, I think, is all moving in the right direction.
Jerry?
It's sad to say that I probably am part of what Damien calls long in the tooth scientists, right? I've been here for a while, and the obvious answer is, and is just, my students are just so much broader than I was at their time. You know, they'll come to me, there's this move of foot, they'll say, well, now we not only publish our paper, we make all of our codes available. And I said, we do? Like, how do we do that? Like, you know, they write papers. 3 or 4 of my students, former students, were part of a paper talking about gender issues. It's in Earth Sciences. I don't know, Victoria, if you saw that in EOS. And you just think those are things that I would never have done. I'm sorry, like, I just would have said, no, I'm going to write the next paper on sea level. Or so to see them maybe starting this process of disruption in understanding how important transparency is in research, in setting up workshops where the same 4 or 5 people aren't always the ones giving a talk, right? It's, you know, I probably spent a decade seeing the same talk over and over again. A very, very famous scientist made a comment at the start of one of her talks that I'll tell you who later, Victoria, but said, it's great to be back at the American Geophysical Union, see old friends and give old talks. So this idea of people just always getting the same figureheads, right, to give, that's just gone, right? And that's a very positive outcome. I don't mind that I'm not invited to give talks. It doesn't, I like it when I see this new faculty member at Purdue or wherever, right? I'm giving a chance, because those people weren't given a chance. Young faculty were not given the same soapbox as older established faculty. So what makes me hopeful is that these younger scientists ignoring those of us who are long in the tooth and just doing it their own way. And I just think much really positive science is going to come of that.
Yeah, that's fantastic. Well, again, given that we've come to the end of our time, I just wanted to say again, thank you so much, Damien, Jerry, and Victoria, for sharing your time with us and your thoughts and giving us all something to be hopeful about and to be inspired by. And again, especially in these challenging times. And just a thought, extend thanks to our audience for participating, and wish you all the best, especially with everything that's going on with your work, with your families and friends, and wish you the best.
And in our return to in-person teaching.
Soon, yes. Yes. Be well with that.
Yes.
Thank you.
Thanks for the opportunity. This was a lot of fun, Jay, and everybody.
Yeah, absolutely.
Bye-bye.